Okay, so we have started the unit number 3 and we are at the last point of this particular unit, and this is going to be covered, that is the applications of PLL. So whatever, this is the design consideration for the FM detector, FSK demodulator and PSK demodulator. So they are the main applications of this PLL, as well as the frequency synthesizer is also one of the major application of this PLL, but that we will see in the next session. So first of all, we should remember that what is a PLL and how they can be used in this the PSK or FSK or FM detector, particularly in detector. Okay. So for that, basically we should know that is what is FM detector, FSK detector and the PSK detector. So detector and the demodulator 99% is the same as that of the, only words are different. Okay. So this is what today we are going to have the discussion on, that is the applications of the PLL, that is phase lock loop. So for that we have learned the IC 565, and in that this is the block diagram we have gone through for the PLL, which consists of the main three blocks, that is phase detector, low pass filter and the VCO. So what is the main purpose of this using the PLL system? Whatever the variation in the input signal is there, so that can be avoided at the output. That is the fixed frequency signal we will receive at the output of PLL. That is the main aim of this particular the PLL. So how it is going to be used in a FM detector or the FSK detector? So a little modification in this particular diagram it is been needed, and that can be used as a FM detector or the FSK detector. So what is mean by the detector? So that also we have gone through. So to extract our original information signal, that is nothing but the detection. And what is the concept of FM detection or the FSK detection? So that we should remember from the earlier subject what we have learned in analog communication as well as in a digital communication. Because I think that FM detection that happen in analog communication and the FSK detection that happen in the digital communication. So that concept you should know. Then and then only how this PLL is being used in that detection method and how the output we are getting, so that we will understand. So this we have gone through the various working of the each of the block in this PLL. So this is the commonly used PLL, that is LM565, the pinout diagram, and how this the internal connection or the structure is there of this 565. So that also we have seen in last session. So how they are going to be connected, what is the use of this R1C1, R2C2. So that also we have seen. Okay. So this is the pin description we have gone through. These three formulas are very important as far as this particular the diagram is also concerned over here, that is the lock range and the capture range. So what is this particular the lock range? So lock range is nothing but the maximum frequency range in which you can lock the input signal. Maximum frequency range in which we can lock the input signal. And then what is capture range? So capture range, it is the similar, it is the frequency range which is similar to the input frequency signal, and that will be always less than that of the lock range. So as it can be shown in this one. So the mathematical formulas to calculate them, that is the FO, that is it is the known as the free running frequency. So free running frequency, it is related with the VCO, that is voltage controlled oscillator. After that, the lock range, that is the this FL, this is the big frequency range, that is max, this one, and FC, that is the this short frequency range, which is similar to this is the what equal to the F oscillator. So F oscillator, this is the frequency that is also equal to the this center frequency. So FO is equal to FOSC, that is oscillator frequency. Don't forget this terminology. Otherwise, here FO is written, here FOSC it is written, so it may be different. Some different meanings are there. So it is not the thing. So FO is equal to F oscillator. So in which mode they are running? So basically 3 modes that we have gone through. That is free running mode means when there is no input, it is called a free running mode. When there is an input, it is called a capturing mode. So it is trying to capture to go near to the input signal frequency. That is called a capturing mode. And once it will reach to the perfect the input signal frequency, so that mode is called a lock mode. And once the this lock mode it is in operative, so afterwards, so fixed frequency output you will receive at the output of PLL. So this is how this PLL is going to be worked. So that we have seen yesterday, that is how it is going to be locked, this particular the phase difference concept. Phase lock loop it is. So the phase, it is the same difference at any instant. So in this diagram, it has been shown. This is they have taken at this moment first and afterwards here. So at both the places, the phase difference is remaining the same. So what is the meaning of this phase difference is same? So that also we have gone through. So phase difference is same means both the signals are having the same frequency. This is very important statement. If phase difference is constant, then both the signals are having the same frequency. Got it? So up to here we have gone through. Next we will go for that additional example also we have seen yesterday. So I hope you all of you has gone through this particular the example and you have solved this and got the answer for this particular whatever it has been asked. If not, try it afterwards whenever you will get the time, but it should be there in your notebook, this problem. Now come to the today's agenda, that is the applications of this PLL. So which are the main commonly important applications of this PLL? So it is for the synchronization and demodulation circuit. So this is the general application of this PLL. It has been mentioned over here. Second, clock recovery. Third, noise and jitter reduction. Next, frequency synthesizer. And last one, it is given, that is the microprocessor. So in microprocessors also PLL is being used, that in a chip. So what is the purpose of using over there? That is as a clock multiplier and clock distribution. So those who gone through the, what we can say, the computer configuration. So that time P4, P5, nowadays that is the this range it is coming, Core i3, i5 processors are coming with the computers or the laptops. So in that also they are having the same model but different pricing, if you have observed. So i5 is there, so that laptop comes in a 60,000. Of the same company, of the same processor, it comes also in a 70,000 also. So what was the difference, or what may be the difference between them? If both the i5 are there, the other configuration is also the same, the RAM and other all the things, but still there is a cost difference. And this is what the here this clock multiplier, because we know that even though the processor is there, to process the instructions there should be the clock signal, because as we know that each instruction requires some specific clock cycles to execute, and this number of clock cycles, if in a per second, if that clocks will be the more, so no, more number of instructions will be get executed per second. And that is what the frequency concept comes over here, that is clock multiplier. So whatever the laptop comes in a 60,000, so definitely the clock frequency, it will be less for that one. And those the laptops comes in a 70,000. So definitely the clock frequency of that will be the more than the earlier one. That is what the difference you can observe. You can go through the specifications also online if you have the interest in that. That is, the both the models are i5 only, but there is a cost difference. So definitely you can adjust also by making the hardware changes, but for that you should be the expert in that, or you can take the help of this particular the dealer to increase the speed of processor. That is the main aim, and that is what the main last application of this PLL also, that is clock multiplier. So how it can multiply this particular clock, so that also we will see. Frequency synthesizer is also the same concept. That is, whatever the input frequency will come, you can increase or decrease this particular frequency. That is by using the multiplier or divider. So that is the frequency synthesizer. Noise and jitter reduction. So noise, we all knows that it will be the high frequency components which will be available in the signal, and that can be reduced. At the same time, the jitter. What is this concept of jitter? Is anybody knows? In analog communication, I hope this concept or this particular word has gone through. What is this meaning of jitter? So jitter, it is nothing but it is a spike noise. That is, if constantly it goes the 100 kilohertz the frequency, and in between suddenly it goes to the 1 megahertz frequency, and it goes less to that the 50 hertz frequency, and again come back to the its original level. So this type of jitter, it is not at all expected in this particular the communication at least area, because that just disturbs this particular the communication, and the appropriate output you will not get. So to avoid this particular the noise and the jitter, this PLL is also been used. How? Because in the PLL itself there is a concept of low pass filter, and which reduces or which cuts off the high frequency signal, and it just passes the low frequency signal. So normally the jitter and the noise, they comes in a upper category. So it is possible to reduce or the remove from this particular the output frequency. Then the clock recovery. So that is the main purpose of the or this PLL system, is that clock recovery means if the original input clock it is of a 50 hertz, and due to some parameters it gets fluctuation. So to get the exact 50 hertz at the output, this PLL system can be used. How? By using the particular the VCO frequency. That is, if you set the VCO frequency is at 50 hertz, so whatever the signal it will come at an input, so it may be 52, variation is up to 55 hertz or 45 hertz. So it will just minimize that one, and constantly the phase difference will keep the same one. And this is how the clock we can recover by using the PLL concept. So this is only I am just telling the theory. Main the applications which we have to see, which is mentioned in our syllabus. So in the next slide or the next part, we will learn. Next one, that is the synchronization and demodulation. So that is what in our syllabus it has been mentioned. So synchronization and we have studied in earlier sessions, that is the main difference between the synchronization and the asynchronization type of the detectors. As we discussed, at the transmitter end, whenever we are sending the signal, we are adding the carrier signal, is it? And at the detector side or the receiver side, we are extracting, we are removing the carrier signal. So the same quantity of carrier signal which has been added at transmitter should be removed at the receiver end. And for that sake, the same quantity of that carrier signal has to be used at receiver end, and that is known as the synchronization detector. And if it is not been used at the receiver end, so that will be called the asynchronous detection. So this is what the main difference between the synchronization and the asynchronization type of the detector. And the demodulation itself, it is we know that to remove the carrier signal and to get the original information signal, that is the demodulation circuitry are there. So this is how this particular applications are here. That is FM demodulation. For AM demodulation also it is going to be used. Frequency synthesizer, signal recovery, and timing distribution. Right now we have whatever discussed here. So it is the theory part, it has been mentioned over here. And now we will just go one by one. If you want, you just note it down all these applications in bullet points. No need to write the particular the explanation for this. I will just keep this slide ahead so that you can just go through it. So in FM demodulation, one major phase lock loop application is the FM detection or demodulation. With PLL chip now relatively cheap, this PLL application enables high frequency audio to be demodulated from the FM signal. So what is this? We will see ahead. AM demodulation is also the same one. Frequency synthesizer. So used within the frequency synthesizer is one of the most important phase lock loop application, although direct digital synthesis is also used. Indirect frequency synthesis forms one of the major phase lock loop application. That is a synthesizer. If you will find the meaning of this particular word, so it will be having the multiplication or the division. So from one particular signal, we will get the multiple copies of it. It may be same, it may be more, it may be less than the original one. So that is known as the synthesizer. So how it be possible, we will see ahead. Signal recovery. So that is also nothing but this particular the clock recovery. We have seen this the in applications. So how it can be get the clock recovered from this one. So for that, how this PLL is going to be used. So that is also useful over here. Timing distribution. So another one of the application, that is the precisely timed clock pulses. Means in some applications, one circuit requires what we can say the 10 millisecond working time. For another circuit in the same application, another circuit requires 20 millisecond, another circuit requires the 30 millisecond. So instead of just using the different circuitry or the crystals for generating the clock signals differently, you can use the single crystal, and from that you can make a multiple these timers. That is 10 millisecond, 20 millisecond, and 30 millisecond like this. And this particular you can give as an input to this particular the different circuitry in the same application. So the best example is the microprocessor system. That is the different modules are there, as we know, in a microprocessor. It may be memory, it may be some processor, it may be other peripheral connections. So for each one, different timings are being required. So it can be possible by using this PLL that the fixed timing it is been provided to the different modules in the same application. So this is how this PLL is going to be utilized. So one by one we will let us see. Just I will stop the sharing. So I hope you all are can see the slide in front of you. So I had just downloaded this PDF. In that, the separate PLA applications are being discussed in a well manner. So definitely this is already been attached in our study material. So you can go through it for the details. So first application here, it has been explained, is this the frequency multiplier. Frequency multiplier means whatever the input frequency is there, so that can be get multiple times more than this particular the input frequency at FO, that is the output of VCO. Because if you will see this, so phase detector, low pass filter, amplifier is also part of the low pass filter only, and the VCO, main three blocks are there of PLL. Additional, it is been used, that is the this frequency divider network. Frequency divider network. So how it is going to be used? So mathematically is also they have explained over here, that is how this particular the frequency is get in the phase detector. So in phase detector, it is having the two inputs will be here. Two inputs are here. So, and it is getting compare in this phase detector. And this whatever the difference is there, it will be two frequencies are going to be compared, but the output will be in the form of voltage. So one important thing we supposed to remember over here, the output of phase detector, it is in the form of, excuse, in the form of, it is the voltage, that is known as the error voltage. So even though it is error voltage, some signal will be there. So the high frequency component, it is removed by this particular LPF, and this error signal is getting amplified by this amplifier, and it is sent to the VCO, error signal. And depending on this error signal, the VCO is changing its frequency. Depending on this error signal, this VCO is changing its frequency, and it is again sent back to this particular the phase detector. But in between, this frequency divider network is being used, and it depends on that key, the value of N here divided by N network, the block name is. So what is the value of this N? It has been decided by that the how much frequency you want at the output, is it? So the formula is also been given over here, that is F0 is equal to N into Fn. So at what multiple times you need the output frequency, so depending on that, this particular the value of N is depends. So if you want, you can draw this afterwards, the diagram, and exactly as a frequency multiplier, how this diagram is look like. So this is what the what we can say is that the connection diagram or the circuit diagram for this frequency multiplier. This is the LM565 having the input from the pin number 2, R1 C1, where it is here. C1 it is over here, the R1 it is internally. So in between the pin number 4 and 5, it is used this particular the 4 and 5. So is it mentioned over here? Yes, here. So this is the pin number 4 and this is the pin number 5. And in between this divided by N network, it is been added. So this is what the here in pin number 4 and 5, this is the divide by N network, it is been added. So if you are remembering 7490, what it is? IC 7490. So it is a decade counter. It is a decade counter. It is here. So this is how this particular the in between this divided by N network, it has been added over here. The other things are the same what we have seen in the last session. That is the value of this R2, C2, and accordingly this they have taken the one of the example. So let us, we will see that we have connected the IC 7490 as a divided by 5 network. The output of VCO, that is pin number 4, is not sufficient to drive the IC in between. Okay, this is the additional one. So this is what pin number 4 and 5 they have talked. VCO frequency can be varied with the help of the R1. So where is that R1? So R1, this is the resistors 2K plus 20K. This 20K is the pot they have added over here. So if you will keep this pot at a minimum, so total resistance will be 2K. If this pot you will keep at a max, so total resistance will be 22K. This is the logically. So it is written that is the 20K and the 2K. So from that, the formula also we were having, that is the minimum frequency and the maximum frequency. So for that, 0.3 divided by R1C1. So for that, this is the what for minimum frequency, max resistance should be there. So they have taken the 22K, that is 20K plus 2K. For minimum, it is taken max, and for max, they have taken the minimum. So for getting the maximum frequency, it is required that the minimum resistance. So here only 2K it is been taken. So why not 0? They have taken the 2K it is taken. So in the diagram, you can see 2K ohm, it is a fixed resistor, and 20K it is a pot. So we can make this 0 or the max like this. So this is how this particular the frequency can be. We will get the minimum, that is 1.3636 kilohertz, and the max, that is a 15 kilohertz. So the frequency can be varied during this particular range, that is 1.36 to 15 with a single capacitor. And the other things are that this particular what is the value of capacitor and all this, it has been added. So this is how the multiplication can be done by using the PLL concept. So then the next application they have added, it's the frequency synthesizer. So what is the difference between them? Because we told that the synthesizer is also the same that of. It can be increased, it can be decreased from the main input source. But the main difference is in multiplication, it will be in the range of hundreds and thousands. That is, if the input frequency is 10 hertz, so at output, you will get 1 mega, 1 giga like this in multiplier. But in frequency synthesizer, it is having a minor change. It is having the minor lock frequency in this particular the frequency synthesizer. That is what, if you will go through this the description, you will get that. That is the, if we want to shift the input frequency by a small amount and not in a multiple numbers. If it is the original input frequency is 1 hertz and you need 1.1 hertz. So that is a minor change in that one. So in that, this particular frequency synthesizer, this concept can be used. So how this particular the setup will look like? So this is the what setup for frequency synthesizer, which is added in our the syllabus also. That is the additional, the multiplier is also been added over here, but the multiplication factor, it will be in a very less amount one. And that is going to be added or supplied to the PLL. So whatever these dotted lines you can observe, so they are nothing but the PLL. And this multiplier is nothing but we talked or we discussed about the one of the concept, that is mixer, if you are remembering. So what is this mixer is doing? Mixer is doing the multiplication itself, but the output of any mixer will be, if two inputs are there for a mixer, the output of mixer will be the addition of these two frequencies as well as the subtraction or the difference between these two frequencies. So that will be the output of this particular. So if you will zoom it, so here you will get that KF0 plus minus F reference, either the addition or the difference. Also it can be the output of this particular multiplier, that is the mixer also we are calling it as. And if when it is passed through this LPF, it will just cancel out the high frequency component and it will remains the low frequency component, that is F0 minus the F reference. And this signal, it is passed to the PLL, so that we will get the respective frequency synthesized, this particular the output. So this particular frequency, it has been passed, and through this, the VCO output, it is again come back to here. And whatever the small change we required, so that is going to be locked by using this PLL. And this we got the fixed frequency. Even though there is a variation in the input frequency, there will not be a variation in the this output frequency. So FO here, it is nothing but it's a FO, that is the output frequency. Here we will get this frequency synthesized output. Got it? So multiplier and the synthesizer, they are the nearly the same one. That is the multiplier. Here we have gone through that. This is the multiplier, that is by adding the divided by n network. And here the synthesizer, so in synthesizer they have only added the additional these two blocks, that is a mixer and the LPF additional, because here is also one of the LPF. This is internal to PLL, so here it is the different. Okay, so this is the synthesizer is there. So this is what the explanation for that it has been mentioned here. The mathematical, they have taken one of the example. So how you will get this particular the minimum variation of the 0.2 megahertz if you want. So how it is going to be work in this time. So what will be your input frequency? What should be the VCO frequency? How it is been calculated? So for that, this is the particular mathematical explanation they have provided over here. The same what we have explained, so it is mentioned here also, that is the at the output of multiplier we will get this one, and after passing to LPF it will just remains the F0 minus F reference. The external frequency, it has been selected in such a way that it will be equal to the translation frequency, as we know, for the 0.2 megahertz. So that the minimum synthesization we require, that is of a 0.2 megahertz. So for that, this is the formula. We can say that the logical formula, it is again FO minus F reference is equal to FT. So where is that? We will see FO minus F reference means here. And another one input for this phase detector, that is FT. So they should be same. FO minus F reference is equal to FT. FO minus F reference is equal to FT. So after just making this one, so you will get this particular equation, and in that this particular how much the variation we require, that is the 0.2, and what is the input frequency it comes, so that is the 1. So FO should be, FO means where, this one. So FO should be the addition of these two, that is the 1 and 0.2 megahertz, that is 1.2 megahertz. So the reference frequency, it is getting shifted from 1 megahertz to 1.2 megahertz. So very minor variation it has been happened in the frequency, that is 1 megahertz to 1.2 megahertz. When in the locked condition, the output frequency is highly stable. So that will be stable at a 1.2 megahertz. So this is how the applications are here. So now we will stop here. The next one, that is the FM detector and this FSK detection. So that part we will see in the next session. So as it is a 10:45, so I will take the attendance and then you can join the guest session. I think the link has came on our group. So I will stop sharing. I will take the attendance. Roll number 2, 4, 6, 7, 8, 9, 10, 11, 12, 17, 23, 26, 27, 29 to 33. Then 39, 40, 41 not there. 43. 44. It is not there. 45. 47. 32 is here.
Sir.
Okay. Roll number 32. If you are hearing me, you call me after in the lunch break or whenever you will get the time. Hmm? Okay. I will stop here. Thank you.